Okay. So 2C? Yeah? Mm-hmm. So 2C, everybody had a division problem. So of course, one thing you had to do was to do what? When you divide fractions? Multiply. So pretty much everybody had, let me see if I can create one that was sort of like what everybody had. Alright, so doesn't that look sort of like yours? Roughly? Some of you guys had stuff rearranged, but everybody had something that looks something like this. So, first thing you're going to want to do is change that to times. What else do you want to do? Factor. So the only thing that really can factor is this top dude. Yeah. So how would I factor this top dude? 5 times negative 10. Factors of that make negative 23. You have 25 and 2. You have negative 25 and 2, and then you split up the middle. Turn, and then you, right? I mean, it's really just factor. Remember to multiply by the reciprocal and then kill whatever's common. So this would become, I can take a 5x out and a 2 out. I'm just going to jump to the chase here. So that would factor like this. If you don't see it, just do the steps. And then there's an x minus 5, and there's a times x minus 5, and there's a 5x. So what cancels?
X minus 5.
X minus 5s.
And the x.
5x plus 2, 11. All right. That's pretty much the way yours works, yes. All right, 2b was the same thing. Everybody had a cube something or other, you know, like x cubed minus 27 or something. Let me make it something nobody had. I don't think anyone had a 64. I can't remember. Not sure. And then somewhere there was this trinomial that won't be factored, but if you guys remember my advice I gave you, if you have a cube in one of these problems, you do that first. Because what happens is the big dude and this kill each other. So a lot of you guys were like, I don't know how to factor this. And I'm like, I don't know either. Just stop trying. Get the cubes factored, and you can see what will happen. Is that cool? So everybody on 2b, somewhere you had a cube. And somewhere you had this 3-term dude that didn't want to factor. And he doesn't want to factor. He can't factor. But he will die anyway. He's the big dude from the cubes. That's 2b. Okay, anything else from that quiz? I think we're working backwards through all the problems. 2a, I think, it's like 2b, just easier. Okay. Cool, so you can make those corrections, do tomorrow, if you want as many points back as you can get. So what do you want to focus on? We can do several problems using some idea. We can do specific homework problems. We could do... Yes?
Practice this?
Yes.
1I.
1I. Okay. So one thing that will save you is, what do you always try first when you're factoring? What do you always try first when you're factoring? GCF. Because some problems, that'll be the only thing you can do. If you're trying to do all this other stuff, it's never going to work. Because it's just a GCF problem. Look at number 1I. Do you see how it's loaded with shit? It's loaded with numbers and B's and G's. It's just screaming to be GCF'd. That was different, right? Poor little thing just wants that. That's all it wants. Is that cool? I mean, that's it. It's just a GCF problem. You just take out the numbers and the B's and the G's. Or did you do that? Okay. That's going to be a situation where the last thing is a 1. Because you can take it out. You took it out. Oh, yeah. Ooh, this one's yummy. Is that it right there? We had a problem like this. I don't care what's going on with this problem. No matter what, what's the first thing you do? We're trying to solve this equation. What's the first thing you do? We don't know that. You don't know that. What's the first thing you do when you're solving an equation? Distribute. And in this case, it's foiling, right? Okay, so, because now you're going to write this 2x minus 3, 2x minus 3. So you get 4x squared. Minus 6x minus 6x is minus 12x. Plus 9. Now what happens to your x squares? Cancels. So I got x minus 4 equals negative 12x plus 9. Do I want to make that equal to 0? What's the only reason you want to set something equal to 0 is if you have an x with a different power on it. These guys died. How do I solve this? Of course. Yeah. That's what I was asking about earlier. Come on, guys. This is chapter 2, probably. Yeah, you just add 12x, add 4, or divide. So don't, in your head, say, let me delete this and replace it with, no. Why did we learn how to set things equal to 0? When there was a term that had a power on it different. Then it wasn't like terms. I needed a new way to do it. What happened to that thing? It did. So how do I solve this? The same way I used to. Add 12x, add 4, 13x equals 13. So when we learn to set something equal to 0, I never said, and now this is the way we solve equations. What sense would that make? So on one level, I understand why math students hate math. They're like, well, one day we said solving equations like this, and then he said, no, it's like, no. We had a different level of equation. We needed a new way to do it. If I have an old style equation, I don't need the new way to do it. Is that cool? Does that make sense? A little bit? Not really? At all? So remember, I kept making this big point. Why is it that I need to set something equal to 0? When does it tell me to set it equal to 0? When I have an x with a different power on it. Second power, third power, whatever. That tells me get it equal to 0 so I can factor and solve it. That's the way I have to do it. If I don't have that anymore, I don't need that new method. I can just use the same old method we were using before. Methods don't go away. We just develop new ones for new situations. That's it. Yeah?
On number 4, the numbers you gave for solution, are just the numbers we used to make the trinomial part?
Yes. Yeah. So, I mean, if I knew that one answer to a problem was x equals 5, what factor has to show up in the problem? Where would that have come from? So what's the answer to this problem? 1 and negative 4. So if I told you one answer is 5, what's got to show up? X minus 5. If I told you another answer is negative 2, then it's got to have a x plus 2. If I told you another one equals 0, yeah. Yeah. So that problem sounds really weird at the beginning, but you realize, oh, I just got to think backwards. Here I know what I get as an answer. I should then be able to go backwards. Where would that answer have come from? If you know something forward or backwards, you really know it. That's why I like that kind of question. Yeah?
Quick question on the last quiz 6.
Quiz 6, okay.
When, like I get when it's equal to 0, how if it's like x plus something, x minus something, it comes out like that, and you just write the opposite. But what if it's something like 2x plus?
Oh, no. Okay. So why? So, okay. Do not forget what the main idea is. So if I have 2x minus 7, x plus 5 equals 0. What is the idea here? This number has to be 0, or this number has to be 0, right? So either this is 0 or that is 0. I can make a shortcut for this, but it doesn't change the idea. This is what I'm doing, setting this equal to 0. But of course I can see the answer is -5. That's easy to see. This shit, oh man, I better write it down, solve it like a normal equation. Command.
So do you want us to do that, or do you just want to leave, want us to leave it like 2x minus 7?
You got it. So if I say solve, you better tell me what the hell x is. Cool. Don't say, you know math, Jeff, figure it out. No. Yes? Which one, sir? Oh, okay. So, is this an equation that I can solve the old way? No. So what I need to do, why can't I solve it the old way? Because I have an x with a different power on it. So what way do I solve it then? I get it equal to? 0. And then I factor it. That's fantastic. You have to love that shit. If this was x equals 16x, I would just subtract x, divide by 15, be done with it. Because I can get my x's together. But this is not like terms. Oh, shit. So then I get this equal to 0, and I factor this. Now what's the first step on factoring this? GCF, I love it. Take an x out, and then you're left with something nice to factor further. And then you do just like we did here. Yep. Okay. But that's the trigger. That's the key. When I see x with a different power on it, it tells me to get it equal to 0, get it factored. That's that new method we developed for that situation. You guys doing all right? You guys seem beat up. What week is this? I don't even know. It's pretty deep. We're at least halfway, right?
We're 5 more we go.
Woo! Man. Thanksgiving can't get here fast enough. Yes? Yes?
One of the worst problems. Or shows how to set up one.
For which one, sir?
Either one, 3 or 4, or 3A or 3B.
Oh, well, okay. I don't know why I gave you... I did. I gave you the same problem twice, but oh well. Believe it or not, I know some of you guys are looking at it like, Jeff, one's a photograph, the other's a plot of land, but they're both rectangles, right? So I must really, really want you to know rectangles. Oh no, part B is a triangle. Yay! Okay. So 3A, what do you want to do on both of these? You want to give yourself a picture. And what do you know in 3A? That it's 3 centimeters shorter than twice the width. So which one do you need to know first, the length or the width? 3 shorter than twice the width. Yeah, I got to know the width first because I got to do shit to it to get the length. So I better know the width first or else I can't do anything to it. So if I call the width W, what's the length going to be? No. I love you guys. You're like, what?
2W minus 2.
But I know that the length is 3 less than twice the width. So 2W minus 3. I don't need a separate letter for it because it's related to the width. It's not its own thing. It's not independent. It's related to the width. What's the area of this rectangle? I like it. So I was wanting to get 2 separate answers. One answer is 104 square centimeters. What's the other answer from the picture?
2W minus 3 times W.
I love it. That's the area from the picture. That's the area they tell me. So that's the equation then. That area better be that area. This is just like the perimeter problems from the past, except it's the reason this is grosser is because when I do this, I'm going to get squared. I got to equal to 0. I got to factor it. With perimeter, I didn't have to do that. Why? What's perimeter based on? Addition. What's area based on? Multiplication. Oh shit, I have a chance to have these higher powers on my variables at the factor. So how do I keep going forward here? The biggest mistake, again, is I see people tell me that 2w minus 3 equals 104 or w equals 104. Do either one of these have to be 104? Is that the only way this would? No, this could be 52 and that could be 2. Right? This could be 26 and that could be 4. Right? This could be 208 and that could be 1/2. Holy shit. So what do I want over here? What number do I want over here? If only there was a 0 there, then I can set each one of these equal to 0 and get an answer. But that's not a 0, so what the shit do I have to do? What do I have to do? What does it look like somebody did? This looks factored, doesn't it? So it looks like somebody factored too early. We didn't subtract the 104, so I've got to multiply this back out and subtract the 104 over so I get it equal to 0 when I know it should be equal to. And then what do I do with this? Factor. I love it. So really the first step wasn't any different than what we always do. We always distribute first. Just in most equations we distribute stuff first. And then I say, oh shit, I got a square, I better get it equal to 0, so then I can factor this. I like it. Now this is gross. I like it. Because you get what? You get negative 208. Good Lord, I'm yelling. And then you need factors that make negative 3. Personally, I don't know if I can win you guys over. The better you are with playing with numbers, the easier all of algebra is. What do I need? You need 2 numbers that multiply with this. How many numbers multiply? A lot of shit. I don't want to go through that list. I also need them to add to be negative 3. So for example, like negative 10 and 7, don't they add to be negative 3? Do they also multiply by negative 208? No. So maybe up this up, maybe negative 20 and 17. Don't they make negative 3? And what's negative 20 times 17? Yeah, it's going to be negative 340. Too big. So now it's like a Price is Right game. Even if you've never seen it, I know you've heard it. Higher, lower, lower, higher. More cheese. So, nobody gets that reference? That's too bad for you guys. Yeah, now, I mean, this is where you guys got to realize, oh, this is awesome. It's in the middle of these two. It's in the middle of these two. So so if I said, have you guys ever seen Courage Carolina? Yes? Muriel. So when she turned into a little baby, you don't remember that? More cheese. Okay, sorry. Negative 14 and 11, right? They make negative 3. But when I multiply them, I get negative 154, I think. Right, so it's too low, so I got to go up maybe negative 16 and 13. What's negative 16 times 13? Hey! Now, is that hard to do? No, it isn't. You just have to have a little tiny bit of stamina. We narrowed it down to between these two, so now I can just kind of keep going, bam, bam, bam. It's a little bit of a quick thing. You can just kind of bam, bam, bam. Or you can make a long-ass list of factors of 208. I would rather not. I really want you to understand, why does this method work? I just need 2 numbers that do both things. Who gives a shit if I make them multiply to this first or if I make them add to this first? They have to do both at the end. So let me make a list of things that add to be negative 3. And check to see if they also do this. No, no, no. Yes, hey, I got it. Most of my colleagues do not want to show you this method. It's such a cool method. I don't understand you guys. I don't. They don't understand me either, so. And you guys are like, yeah, we don't understand you either, Jeff. It's the life I picked. To never be understood. Look. So yeah, you would do the middle term, right, is a cool group. You get like a negative answer and a positive answer. Since this is a physical answer, not just numbers, we got to throw out the negative. That's a freaky ass thing. I don't want to see your picture that's negative length. Am I going to get sucked into it? What does that mean? Is it a Twilight Zone episode? Look at this picture. Ah! Negative length. Yes?
We then have to make it equal to 0 after that.
It is equal to 0. But what we're doing here, what am I going to do with these two numbers? Break up the middle term. Group. Set each piece equal to 0 when I'm done factoring. Now, a lot of you guys, when you group, you don't finish factoring. Some of you guys see that on your quiz. It said you're not done factoring. Fully finish factoring before you set each piece equal to 0. So, I mean, right here, somebody with me? 2w squared. That's going to be negative 16w plus 3w. All right? 13, sorry. Minus 104. Group. Keep going. Man, that shut you guys up. What happened? Yes?
1B.
A 1b. What's the first step in 1b? What's your first step always for factoring? See if there's a GCF. Is there a GCF in 1b? Yes, they're both even, so I can take out a 2. And then you're going to uncover a cubes. Little dude, big dude, yeah. Please, dear God. I don't care what it is, you can never factor a cubes like this. Ever, ever. Never, ever, never. Never, never, ever. You can't make this x minus 2, x minus 2, x minus 2. That is not true. Because when you multiply this shit out, aren't you going to get a lot of middle terms? You just are. So how in the world could it possibly equal this that has no middle terms? That's why the little dude, big dude with the cleanup guy in the middle that kills that extra shit. That's the only way it's going to work. I don't blame you for being optimistic.
When we factor it out, do you just leave it at that number?
This one?
No, the other one. The 1B.
I got one prob on here. What's this one? Well, 1B is just, yeah. All right, so you can take a 2 out. This isn't really 1B. 1B, you take a 2 out, what are you left with?
X cubed plus 27y.
What form is this in? 2 terms, so it can only be squares or cubes. And it's obviously cubes. Little dude, big dude, keep going. Just because you did something doesn't mean you can stop. Right? Clean up your room. I picked up one thing. You know. So you did one thing. Yay. But look, there's a lot more left. You're going to lose most of the points if you stop here. Because you did the easiest thing.
How do you do that part?
Oh, shit. So, cubes. How does cubes work? How does cubes work? Have we not done enough of these?
That would be x times x.
Yes, x cubed is x times x times x. 27y cubed, so 3y, 3y, 3y. 2 comes for the ride, little dude, big dude.
X plus 3y.
Yeah, x, one of these, plus 3y. So here's going to go x squared. At the end is going to go 9y squared. And you can kind of check, look, there's my x cubed. Hey, there's my 27y cubed. Hey. And I also got other shit I don't want, so this better be what? Minus 3xy. One of each, 2 of each, product in the middle. Closest to a song I'll get. I really, I don't give a shit if this makes me seem like less fun or whatever, but I hate most songs in math for like learning. That's not learning. That's taking you further away from the idea, and you just go, a bunch of songs. That's what math. No, come on. Sorry. Yes.
So please switch number, number C.
Oh, Okay. So a sum of squares, can you factor it? Using squares. Can you factor this? No. Why can I factor this though? Why is that factorable? Because am I going to factor the squares in this problem? No. What am I going to do? What do I always do first? GCF. So everybody had a problem that was a sum of squares, but there was a GCF. GCF don't give a shit what it's trying to be. You can always take a GCF out, if there is one. So I agree with you, the squares won't work. GCF will. They both have a 4, right? You guys with me? Caroline, you're in the same room.
What number?
Shoot, what was it? Oh, 1C on quiz 6.
For the practice test,
Yes.
is that the same as 1F? Like you can't.
Yes, 1F, exactly the same. It's the GCF,
And you can't.
and that's it. Because it's the sum of squares otherwise.
Can we do 1D where
1E?
D?
D. Oh, yeah,
How
yeah,
would you set up? I know the cubes, but past that.
yeah. Wait. You know it's what?
It's not cubes.
It's not cubes, that's right.
So it's like 2, 2, and 2.
No. It's not cubes. Totally not. Obviously not.
And then 2, 2, 2, 2.
No. What are there's 2 terms. What are the only 2 things it could be? Squares or cubes? That's it. Now what does squares really mean? It means I can cut everything in half. Can you cut everything in half? Multiplicatively. Of course you can. So therefore it's a squares. And then you can say, I don't see any squares in here, Jeff. I do, because I'm a weird math dude. So you can see a whole bunch of freaking squares in there. Right? So if the powers were the 8th power, could it be a square? Yes, because you can cut those in half. 9th power, no. Could it be a cubes? Yes, because you can cut that in thirds. So when I say squares, cubes, I don't really mean only a power of 2 would work for squares. No. Can you cut them in half? So what would the first step be here? Cut everything in half.
X squared minus 4y squared
And then x squared
plus.
Now one of these can go further.
First one.
First one. The second one is a sum of squares. It's done. It goes for the ride. Just comes for the ride. And this one can be rewritten into 2 parts. Right? It's difference of squares. You can go a little further. So when you have a difference of squares that has a higher power on it, just be ready for it to maybe go further. Because you can cut this up in half and you can cut it by half again. What other number would work? 16 works. Because I can cut 16 in half twice, right? 16 is 4, 4, which is 2, 2, 2, 2. What about 81? 81 is what times what? 9 times 9. And each 9 is, see, there's very limited numbers that will do this. That are both, that are squares and then squared again. 2 squared squared is 16. 3 squared squared is 81. 4 squared squared is huge. 256, I think. Yeah. Yes.
So whenever you have the sums of squares, it stays the same.
Yep.
It's okay.
That part is done. That part is done. Yes.
Can we do 6D?
Okay. Is there a certain part of this problem that give you trouble? Because what's the idea of this kind of problem? 6D. What's the idea? What do I do first on 6D? Yeah, I factor everything, right? I still see, 1 is too many, but I've seen more than one person do stuff like, what's this? Gather. I still see people doing stuff like that. What? Why can't that work? Because the minus, yeah. Because the division can't cancel parts of a subtraction problem. You can't do that. So if I had 4x cubed minus 36x, could I kill 4x cubed by dividing? No. I only can kill it by subtracting, right? Because it's positive. It's adding to this negative 36x. I have to use the opposite operation to kill it. Okay, so what do I do on this part? I know there's more to it, but I factor the top, GCF like you said. I factor the bottom. Ooh, it's a cubes. Factor, kill, 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 kill. That is 6D. That's what you're asking about, right? Okay. I want you to separate yourself from the specific, that 6D problem, and go, well, how do I do any kind of problem that looks like that? I factor everything I can, and then I see what's the same on the top and bottom, because I can kill those. That is the idea. So then it doesn't matter. It matters less what I put in there. Whatever the shit it is, you factor it if you can.
When you factor everything, is it okay? Are we killing if it's on top of each other or across?
Yes. As long as, so if I factored something, I ended up with this, let's see. Okay. So can I kill the x plus 8s?
Yeah.
Yes. Can I kill the 4s? Mm-hmm. Yes, because one's on the top, one's on the bottom. I like it. Can I kill the x minus 3s?
No.
No. Because they're not killing each other. They're multiplying each other. They're not going to make each other cancel. They're going to make each other bigger, right? Yes?
So if there was a 2 with the x plus 8, would you count that?
Because there's one on the bottom, one on the top. And that means one's being multiplied, one's being divided. Since they're opposite operations, they cancel. I love it. Exactly why this doesn't work. Division, not the opposite of subtraction. You can't do it. I try to make a big deal out of that. Did I make a big deal out of that?
You think you got a 4.
Nobody wants to talk. You guys ready for Halloween? It's already Wednesday. Oh my God. It's Wednesday, Halloween. I'm trying to figure out if I want to come to school dressed up or not. I used to. Came one time as a pirate. That was funny. I came as an old man. I wore these glasses with no lenses in them. I put wrinkles all over me. I spray painted my hair. Not spray painted, but colored my hair gray and silver. Wore these pants up to here. Somebody came by my office and they told me later, who was that guy in your office yesterday? It was me. Sorry, that was fun. Yeah.
I'm just stretching.
Oh, okay. I got to do the in my day jokes. In my day, we didn't have amusement parks. We didn't have shoes. Yes?
I just have this all.
I don't know. I'm thinking about it. I'll open up to you guys. I'm a little bummed out because I had a girlfriend who had 2 kids and we just broke up a little while back. So I'm a little bummed out. So I'm trying to gauge where I am. I was looking forward to trick-or-treating with them. I bought them all these costumes and stuff, and now I'm not going to see them. I'll be all right. I'll cry later. I'll hold it in. So, she might watch this, yeah. Anyway, sorry. Don't have to air all that in front of you guys. You know what you did. All right.
You have a daughter though, right?
No.
You don't have any kids?
I don't have any kids of my own.
Oh, I thought you had a kid. Like your profile picture.
Oh, that's my niece. That's my brother's daughter. Yeah. Huh? They're on the East Coast. They're in Virginia. Yeah. Sorry, I derailed the math conversation.
You drop 15. You drop 15.
Yes.
6.
6E? All right, so that's, oh, the one part of that that's a little freaky. E, right?
Yeah.
The one part of that that's a little freaky is this first dude here. The rest of it you factor like always, but do you notice how this is backwards? Does that make sense when I say that? Because the bigger power was second. What you almost always want to do in that case is take a negative out. Because when you factor the bottom, you're going to get a b minus 3 term. Where'd it go? Yeah, you're going to get b squared minus 1, b plus 3. Not b plus 3, b minus 3. And you can factor this further. But do you see how if you factor the top and you just take a b out, it's going to become 3 minus b? Do you see how that's backwards from what it should be? So if I just took a negative b out, what's it become? It becomes positive b minus 3. Now those would cancel. So almost always when you see it out of order, the higher degree is further. It's negative. You want to take a negative out so it turns back around.
How would you factor that one further?
This one?
Yeah.
How many terms? 2. So it can only be squares or cubes. I want you to realize that's why most everybody teaches it that way. If you just so you don't have to remember all the forms. You go, okay, it's 2 terms. It could only be squares or cubes. Now you've totally focused yourself on something instead of going, it could be anything. You know, that would be insane. But 2 terms, no GCF. It can only be squares or cubes of anything, and then you can really whittle it down quick. 3 terms. It can only be surefire, or it's easy if the first one's a 1. 4 terms, grouping, or, you know. That's why you want to start there, so you know what methods to focus on trying. Instead of just, let me try everything, which is some people's favorite approach. But then you don't get done with that. It's the end of the test, and you've only done one problem, because you've been trying everything. Oh my God. I want to remind you guys about something. Well, let's see. How do I factor b squared minus 1?
B plus 1, B minus 1.
Can I factor b squared plus 1? No. All right, that's a fact, right? That's it. That's all you got to worry about. But what if b is 7 here? What is this number? 7 squared is 49 plus 1 is 50. Is 50 factorable? Yes. So why doesn't this factor then? Because it doesn't work all the time. If an expression is factorable, it will work no matter what b is. Make b 4. What do you get? 17. Can you factor 17? No. Then this can't work at all. If there's one number it doesn't work for, it's not factorable. That's really neat. This factored, therefore, no matter what the shit you make b, this is how it will factor. Let's make b7 here. What do I get if I make b7?
48.
Yeah, I get 48. And how do you factor 48? 7 plus 1 is 8. 7 minus 1 is 6. And that's neat shit. I really, really hope you guys... What about if b was 5? What's this? 25 minus 1 is 24. How do I factor 24? 5 plus 1 is 6. 5 minus 1 is 4. Do you see that shit? Is that going to help you factor numbers? No. It's just showing you what you're really doing. If something factors, that means whatever the number would be will factor. Like this. If it doesn't factor, that doesn't mean that every number that I can get out of this doesn't factor. It means that not all of them factored. All I need is one thing that I put in here and I get a number, it won't factor, then I can't factor this. 7 worked, but what did I use? 3, 4, 4 didn't. Anyway, sorry. All that is side news. I'm sorry. It's nothing you have to worry about to be able to pass this class, but is a neat side step to take to really understand what the shit's going on. There's stuff you have to do to pass, and there's stuff, if you understand it, you will have an easier time passing. I don't mean dying, I mean passing the class. And I can shut down a conversation quick. I'm a math teacher, so buzzkill, I'm used to that. That's all good.
3B?
3B. Oh yeah, 3B is awesome. 3B is that triangle prob. So again, what's the good first step on 3B? Draw the picture. What's it say? It says the base is 20 feet shorter than 3 times the height. So I got base and I got height. Which one am I going to give a letter first? Which one does the other one depend on? Height. The base is 20 feet shorter than 3 times the height. So if I call the height h, what's that make the base?
3x minus 2.
What is it? 3h minus 20. Or you can call the height x, that's fine, whatever you want to. Doesn't matter what symbol you use. Now what's the area of a triangle? What's the formula?
12 plus 2,
Say again?
like 2 times.
It's half height times base. Half height base. Sorry. Well, I made a stupid song a while back about it. Yeah, the area of a triangle is 1/2 base times height. Why? Because the area of this is base times height, and a triangle is half of it. Yay! So that's why the area of a triangle is 1/2 base times height, because every triangle is half of this parallelogram kind of thing. So, what is it supposed to equal? That's what it looks like in symbols, and in numbers, it's supposed to be 2,000. Oh, that's yummy. You have an equation with a fraction in it. What's a good first step? There's an equation with a fraction in it. I can multiply by 2. So then I don't have any fraction. I can distribute this h. And what does this tell me to do next? I don't want to do it, but too bad. Yes, get it equal to 0, try to factor it. You get 12,000. Sorry. That, I'm way too excited about that. It's funny. Subtract 4,000. Right, so you get 0 equals this. So you need factors of negative 12,000 to add to be negative 20. Do you want to make a list of factors of 12,000? How many factors are there? I'd rather do that thing again. What 2 numbers subtract to be 20? Give me 2 numbers that subtract to be 20. 40 and 20. As long as 40 is negative. But what do these multiply to be? You can do it. 40 times 20. What's 4 times 2?
800?
Yeah, 8, 2 zeros, negative. Is that what I need?
No.
Way too little. So let's take a big step up. Let's do like negative 80 and
40, 60. No.
60, sure. What's negative 80 times 60? 8 times 6 is 48. 2 zeros. All right, we're getting closer. What about 100 and 120? Don't they add to be negative 20? And they multiply to be negative 12,000. That's why I like this. You can zero in on it so quickly. My colleagues say, how long is a list of things that subtract be 20? Infinitely long. Did I make an infinitely long list? No, I can zero in on it very quickly. That's the thing they don't understand. I don't know. I'm like, you should understand it. You're math people. What the shit?
Which one?
Most of them, which doesn't make sense to me. I don't know. Does that, you can be really honest, does that method make any sense to anybody? Because what do you normally do? You normally get taught to make this long list of factors of this number and check to see if they had to be this. There's nothing that says I can't do it backwards. I just need them to do both at the end. Make them do one of them, check to see if it does the other thing. If it doesn't, guess again. This way I can really guess smarter. Too small, let me make them bigger. Still too small, let me make them bigger. I mean, that just makes beautiful sense. That's my hope. I'm always hopeful.
We do 5B.
All right, we'll do this one, and then I'll give you the answer key. So you guys are getting antsy for that. I'm sorry. You guys still copying that? It's on there. Is that still going? Is it still going?
Oh, yeah, it's still going,
Adrian, you're like, no, it stopped a while back. I was like, damn. 5B? Look how, all right, I really want you guys to identify how 5B is easy. I'm not just saying that because I'm a math guy. Why is this one easy? Both denominators are the same. What's the only one that doesn't have the same denominator?
5.
What's on the bottom of 5 currently?
1.
So what's it need?
A plus 3.
I always have somebody who just puts an A plus 3 there, not there. And I'm like, how does the top stay the same but the bottom changes? It's impossible. So what can I do now that they all have A plus 3 in the bottom? Multiply by A plus 3. Because then all my fractions go, if I make all the bottoms the same, I can multiply by that thing, all my fractions are gone. Sorry. 99 problems with the denominator, one of them. So we got bam, bam, bam.
Oh my God.
I know, I said that. Weird things come on my head. Sometimes I can't stop that. Do you guys see that? That was over A plus 3. I made that become over A plus 3. And that's over A plus 3. So if I multiply by it everywhere, it all cancels. So then I get A plus 5, A plus 15 equals 4. It's a couple steps away from done. Let me give you this answer key here.
When we're testing it out.
I don't remember. That's why I did that homework sheet. So I didn't have to stand here and know it all at the moment. So if you look at your homework sheet, you can see how many more tests we have left. And then we got a final exam.
We have 2 more tests.
2 more tests, and then a final? Yeah.
Do we have, are we having class Wednesday,
Yes, Monday and Tuesday. We're supposed to have class Wednesday, but I always give my classes off Wednesday. Some of us have to travel.
This Wednesday?
No. Thanksgiving. Thanksgiving.
When is it?
The last.
The end of this month. Yeah.
No, this one?
Yeah.
So no school, huh?
Not my class. If you have other classes, the school isn't out the Wednesday before Thanksgiving. You understand? The school is crazy.
We're technically only supposed to get Thursday and Friday.
Yeah, you get Thursday and Friday off, so you can eat turkey and then go stay in a line to get something, some TV. Or PlayStation. PlayStation. Huh? I'll remind you as we get closer, but it's not any Wednesday soon. We haven't even made it to Halloween yet, guys. We haven't even made it to Halloween. There's Christmas decorations up like a month ago. I saw them up on Friday.
I had one the day, what was it? Like, the day before in October. Someone already had it up already.
You could be done whenever you want to. This is college class. You don't have to be here.
I have a question just on test 2. No, test 2. The word problem one.
Okay.
The kickback one.
That's 2. That's a while back. Shoot.
I just, this is how I would set it up.
What's that? 3.
Oh,
Yeah,
test
there you go.
2, sorry.
This is right.
And then we're gonna multiply this by 10 and then just like.
And then yeah, and then you can do elimination.
So why, like how do you, I feel like this problem is obviously leading it, getting to that point.
We have 2 ideas. You have an amount, and you have a total price. So here's the amount. Here's the price. So one of the first things you do on that kind of problem is identify what the 2 ideas are.
So we would ignore the part which is.
That's just the name of the 3 Musketeers canon. The 3 Musketeers, right?
Oh, 2 people.